Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the topic modern periodic law and a modern periodic table. So let's first of all talk about the scientist who has given this thing, and he is Henry Moseley, the scientist who proved that atomic number is more fundamental property of an element than its atomic mass. You can see the picture of Henry Moseley sir on the screen. So now let's discuss some points one by one. Let's come to the very first point. We must bear in mind that when the Mendeleev developed his periodic table, chemists knew nothing about the internal structure of the atom. However, the beginning of the 20th century witnessed the profound development in the theories of subatomic particles like electrons, protons, and neutrons. Now let's come to the second point. In 1913, the English physicist Henry Moseley observed the regularities in the characteristic X-ray spectra of the elements. He found that a graph of frequencies of X-rays versus atomic number of elements from which the X-rays have been emitted. The graph was a straight line, but not with the atomic mass of that element. Thereby, he concluded that the atomic number is more fundamental property than the atomic mass, because the graph was straight line with the atomic number but not with the atomic mass. Now let's come to the third point. Mendeleev periodic law was accordingly modified and can be stated as: the physical and the chemical properties of an element are periodic function of their atomic numbers, not the atomic masses. Now let's come to the fourth point. This periodic law revealed important analogies among the 94 naturally occurring elements. Now let's come to the fifth point. We can recall that atomic number is equal to the nuclear charge, that is the number of electrons or the number of protons in neutral atom. It is then easy to visualize the significance of quantum numbers and electronic configurations in the periodicity of the elements. So the periodicity was actually dependent upon the electronic configurations, the quantum numbers, the atomic numbers, but not on the atomic masses. Now let's come to the sixth point. The periodic law is essentially the consequence of the periodic variation in the electronic configurations, which indeed determine the physical and the chemical properties of the elements and their compounds. Now let's come to the seventh point. A modern version, the so-called long form of periodic table, is widely accepted according to this new periodic law. So that long form of periodic table is this one. You must be familiar with this one. Now let's come to the very next point. The point number 8. The horizontal rows in the periodic table are called periods and the vertical columns are called groups. So now let's identify the periods and groups in the periodic table. So the elements which are arranged in horizontal rows, these horizontal rows are called periods. These horizontal rows are periods. This is also period. So the horizontal rows are called periods. Now let's come to the groups. These vertical rows are called groups. These are groups. The vertical rows are called groups. And whereas the horizontal rows were called periods. So now let's come back to the points. The ninth point. As we move through a period, the atomic number is increased by 1 unit at each successive element. Now let's see this thing in the periodic table. Carefully examine the periodic table. Let's talk about a period. Let's start from the lithium. Here the atomic number is 3, then 4, then 5. So the atomic number is increasing by 1 unit for each successive element in a period. So the next one is 6, 7, 8, 9, 10. Now it's 11, 12, 13, 14, 15, 16, 17, 18. That's 19, 20, 21, 22, 23, 24. So I hope you got the point that atomic number is increasing by 1 unit at each successive element in a period. Next one is 25, 26, 27, 28, 29, 30. That's 31, 32, 3, 34, 35, then 36. So this is the thing. Now let's come to the next point. The point number 10th. The elements having similar electronic configuration in their atoms are arranged in the vertical columns referred to as groups. What's the significance of groups? The members of the groups have similar valence shell electronic configuration. We are going to study this thing in detail in the further topics. Now, let's come to the 11th point. There are altogether 7 periods and 18 groups. The period number corresponds to the highest principal quantum number of the elements in the period. That means the period number is equal to the main shell number in which the last electron is entering. Let's come back to the periodic table. Firstly, here you can see that how many periods are there. That's the period number 1, the horizontal row. That's the period number 1. Period number 2, period number 3, period number 4, the period number 5, the period number 6, and finally the period number 7. The period number corresponds to the, I'm writing, that's period number, and it corresponds to the number of main energy shell, number of main energy shell in which the last electron of that particular atom is entering. So the first shell gets completed in the first period, second shell gets completed in the second period, the third shell gets completed in the third period, the fourth shell gets completed in the fourth period, the fifth shell gets completed in the fifth period, sixth shell gets completed in the sixth period. Finally, the seventh shell gets completed in the seventh period with atomic number of 118. One thing more. How many groups are there? Now let's talk about the groups. Now, that's the group number 1. The hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. The group number 2, the group number 3, the group number 4, the group number 5, the group number 6, like this one, the group number 6, group number 7, group number 8, group number 9, the 10th, the 11th, the 12th group, the 13th group, 14th group, 15th group, 16th group, 17th group, and a very last 18th group. So we are having altogether 18 groups and the 7 periods. In group, we have the similar outer electronic configuration of the elements which are constituting that group. So the members of the groups will have the same outer shell electronic configuration. Now let's come to the next point. Now, the point number 12th. The first period contains 2 elements, subsequent period contains 8, 8, 18, 18 and 32 elements respectively. Now let's come to the 13th point. The 7th period is incomplete as some of the members are still undiscovered, and like that of 6th period will have a theoretical maximum of 32 elements. Now let's come back to the periodic table. Now here let's evaluate how many elements are there in the particular periods. Now in the very first period we are having two elements, the hydrogen and the helium. The period number 2 contains 8 elements. The period number 3, 8 elements. The period number 4, 18 elements. The period number 5, again 18 elements. The period number 6, 32 elements. So where are these elements then? These 14 elements are where? So these 14 elements are placed separately over here, and that's called lanthanoid series because they are starting from the element lanthanum. Now let's talk about the period number 7. The period number 7 is incomplete as some of the members are still undiscovered, which are like the element number 113 is undiscovered, 115 is undiscovered, 117 is undiscovered, 118 haven't discovered. Its name is Ogneson, right? Its name is Ogneson, right, these days. So the period number 7 will have again a theoretical maximum of 32 elements ending at 118. So now let's talk about these 59 to 103. Where are these elements? These elements are again placed in the separate panel, and they are called actinoid series because they are starting from actinum. Now let's come back to the points. The point number 14. In this form of periodic table, the 14 elements of both 6th and the 7th period, the lanthanoids and actinoids that we have just discussed, are placed in the separate panels at the bottom. So that's all for today, and it was a very important topic. Please do have a very careful look of the periodic table. In the next lectures we are going to study why this periodic table has this type of shape. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.